welcome back to the top-down shooter tutorial. And in this video we're going to look at creating the player controller. So what we're going to do here is we're going to add in a new scene and other node. This is going to be a kinematic body. Now what a kinematic body is it's an object that will interact with physics. So we can make it so that it doesn't actually go through the walls. And if you remember, on the wall panels, we have put static bodies there. So it's not going to be able to move through those, but it will still be able to move. But it's not going to act like a rigid body. So a rigid body will act kind of freely within the physics world and act fairly realistically. This is just going to be a kinematic body. It will move around, but it will still interact with other physics bodies. So what we're going to add to this, first of all, is before we do any kind of character modeling and adding meshes in there, we're just going to get it working by using a mesh instance, which is this one here. So mesh instance, and I'm going to add in a capsule mesh. Now I don't know why it decides to add it sideways. It's really weird, but I'm going to rotate that. We're going to rotate that so it's upright, and I'm actually going to scale it down a little bit because that's too big. So I'll go to the transform, and not the transform there, geometry, where is it? Oh, there, mesh. Click that, and you can change the detail of this. It doesn't really matter because I'm just going to turn it down to 48. But there is a way to change the, here we go, radius. I'm going to change that to 0.5, and that's a bit better now. Okay, so 0.5 is good. I'm going to move it up 1 unit. All right, so it's going to kind of sit on the ground there. So that's cool there. But what we need to also add is like a pointer, because we're going to make this rotate towards the mouse. And at the moment, there's no real way to see where it's pointing. So we're going to add another mesh instance, and this one is going to be a prism mesh. Now this prism mesh, we want it to actually rotate and point along the z-axis this way. At least that's the way I've written the code. There may be another way to do it. And I'll scale that in. So if I click on mesh there, we're going to change the size to, I will change that to 0.2. And that's going to be 0.5, and the z-axis will be 0.5 as well. And then I'm just going to move it so it kind of sits there. All right, so that's going to just tell us which way we're pointing. So that'll work. I want that to be a child of the kinematic body, not of the thing. So we'll call this point direction, and we'll call this one capsule mesh. I'm not going to refer to them, it's just so I know which one they actually are. Now we need to have a position 3D, but we're going to add that in because that's going to be where the bullets come out of later. So let's go ahead and add a position 3D, and we're going to move that. I'm going to make sure it's a child of the kinematic body. It's going to be, well actually that's pretty good because we're going to position the gun about here. We can move that later on. Lastly, the kinematic body needs to have a collision shape. So we're going to put that in, collision shape, and it's going to be a capsule shape. Once again, it's like this, I'm not sure why, but let's rotate it upwards, and we're going to make sure that I use shift to bring that in and bring it up, and it should match that other one in there. Now it's not a big deal if it doesn't, but that's good for now. Okay, so what I'm going to do is I'm going to save this as player, and I'm going to rename this to be player. Okay, so we've got our player kinematic body. Now, if you have a level designed, it would be a good idea to go ahead and open that up now. So I'm going to do this because we're going to program it in here and add some stuff into this level. I'm just going to bring the room in that I've designed. So there's that room we've designed, and that's cool. So I'm going to put the player in there as well, and there they are down there. You see the way that I've kind of designed everything, it's just very easy to put stuff in here. And that's good. Now we can start programming this, and we will add a script to this player. Now we can add it here or we can add it in here, but it doesn't matter because it's going to get attached. Now I'm going to save this as level 1 or level test level for now. Okay, it's good to have a test level. All right, so let's go ahead and add a script to the player. We're going to call it movement, and I'm going to leave the template as default, and it's going to inherit from kinematic body. Now, all of this stuff, you can just leave it. Okay, so we can delete this stuff here. It's just some code comments that are in there. We can actually pretty much delete it all, and all we want is extends kinematic body. Now, at the top, we are going to grab some stuff. First of all, we do need to add a camera to this room as well. So we're going to add a camera, and this camera, you'll see it goes right in there at 0, 0. We're going to pull it up quite high. For some reason, the camera doesn't snap, but I do have snapping turned on. And then we're going to rotate that camera to be pointing down, like that, 90 degrees. If over here, we're going to set the transform, we'll just go 10 for on the Y, and then negative 90 for that. And if you hit play, play on that scene. Okay, there we go. We should see something like that. We may have to rotate the camera if it's not working properly, but it looks like it's all good. It looks like it's that way, and everything else I've done seems to be that way. So we'll see what happens. But I'm going to open up the script for the player. Now what we're going to do is we're going to set up a few different variables to start with. So on ready. What this means is when the script loads, it's going to get this variable and kind of store it for us. Camera equals get node, and we are going to get the camera node here. So to get this, we can actually say, well, since this is the parent, we can get the camera from there. So we can say get parent dot get node camera. Okay, so the player is here, its parent is there, and then we could say get node camera. We could say get child, but it's going to be get child 0, 1, 2, and it's not guaranteed that camera is always going to be 2. We might end up adding something in and it's not the right child node, so we want to just make sure we get it by name. Okay, another thing that we're going to need is to export var max speed. Now I got some of this code from some top-down 2D tutorials by Heartbeast and a few other people. So I've kind of hacked it together and also made it my own. So you'll see some of this might be familiar. They did 2D ones though, so I kind of adapted it for 3D. So we're going to add some friction here, equals 10. I don't think I ended up using the friction, but I'll put it in case we decide to add it in later. Speed equals 1. And variable move vector equals vector 3.0, and then variable cursor position equals vector 3.0, and we'll come back and add some more stuff in here later on. Now what this export does is it means that if we click on the player, we get those variables over there. So if we just want to change something for testing, we can test them or change them in there instead of having to go into the script all of the time. All right, now we're going to open up, we're going to create a new function here. Process. Delta. So delta is the kind of the time between frames, how much time the previous frame took. I think, at least that's how I understand it. And so we can multiply things by delta to kind of smooth out the speed of things. Okay. And we're also going to add in a func physics process. So that's also going to have delta in there. Okay, then in here, we'll just type pass in here just so it stops giving us errors. So in here, we're going to get the player input. So we're going to have variable input equals get input. Now this is a function, get input, but it doesn't exist yet. It says down the bottom, the method get input isn't declared. I'm going to actually write it. So func get input. And what this function is going to do is it's going to get the player input, variable input. And you may have seen people do this with vector 2s quite a lot. I used to do this a lot in Game Maker as well, and I don't remember where I picked it up from, but it is something I've done for a while. I'm pretty sure Heartbeast does this as well. Import dot is action pressed UI left plus int, and we need to convert it to an integer because it comes through as true or false, but you can convert true or false to an integer in Godot, and it will either be 1 or 0. So what's going to happen here is we're going to end up with a vector 3, which is what we need in 3D. We put a comma here, and then we want 0 on the y-axis. We never want the player to move up from our input. And then I'm just going to copy this and change the values here. That's going to be UI up, and that's going to be down. And I've made a mistake here. That should be there, and that should be there. That looks right. UI underscore, I think I put a, yep, there we go. UI underscore down. I don't need that on the end there. Okay, so what's going to happen here? var input equals vector 3, and what this will do is it will check to see, are you pushing the left key? If yes, it will be 1 or -1 in this case. Are you pushing the right key? If yes, it will be 1. So in this case, if we're pushing the left and right key, it's going to be -1 plus 1, which is 0. So we don't move any direction. But if we're only pushing the left key, it's going to be -1 plus 0, which is -1. If we're pushing the right key and not the left key, it'll be 0 or -0 plus 1, which will be +1. So we're going to get this vector 3, which is going to give us the direction on the keyboard that we're pushing left, right, up, down, etc. And then we can adapt it into player movement. We are going to input equals input.normalized. And this will just mean that we don't move faster on diagonals than we do on just straight up left and right. And then we're going to return the input. Now what the return does is it calculates all these values and sends it back to here, stores it in this input variable. So we've got that player input. Okay, so continuing on from there, we're going to check if input is not equal to vector 3.0. Okay, so if it's not equal to vector 3.0, so there is some player input, speed plus equals 0.1. So we're going to increase the speed, and then if speed is greater than max speed, speed equals max speed. So this is going to slowly increase the speed variable, and if it's greater than the maximum speed, so it gets up to 10 or whatever, then we're going to slow it down. Now, if you want it to accelerate faster, we can put it at this. Now we could actually go up to the top here and go export var acceleration equals 0.5. And I'm just going to say acceleration. Okay, if speed is greater than max speed, that way we can change the acceleration, play around with how it feels, and that'll work pretty well. Okay, then we do this. Move vector equals input times speed. So we've got the input. Now you can multiply a vector 3 by a single number. It's worthwhile if you're interested in 3D programming, doing some basic maths, learning how vectors work, learning how you could multiply a vector, even learning about matrices is pretty cool, and how matrices work. In fact, you can see over here that Godot does utilize matrices. And there's some stuff you can do with that if you're a bit more advanced. Okay, so we're going to do that, and then we're going to move and slide along our move vector. Now I'm keeping this simple. If you've seen other tutorials, you'll know that this is pretty basic compared to what we could do. We could have a whole lot of friction stuff, which I haven't added. We could keep the amount of movement between it and so on. I'm just keeping this simple. So if I run this scene now, we'll save this and run this test level, I should be able to move. And it looks like I've got the movement correct. I shouldn't be able to move through the doors, through the walls. I should be able to move through the door though. And of course my character won't fall down because it's a kinematic body, not a rigid body. So gravity doesn't act on it. Right, now, what we want to do now is make sure that the camera follows the player. So let's go ahead and do that. Let's get that camera. And I'm pretty sure I put the camera code on here, but I'm looking at my previous one and it looks like I didn't. Maybe I put it on the actual camera, which would be a stupid thing to do. I did, but let's put it in here anyway. So let's go to process here and we're going to say variable camera pos equals vector 3. And then we'll say camera pos dot x equals translation. That's the player's translation. Now what the translation is this x, y, z coordinates of the player. I'm not sure why it said ABS there. X, y, z coordinates of the player. Actually, I do know why I put it on the camera, because I want to have some camera shake effect later. So we will put that in the camera. So let's go over to the camera and we're going to add a script for the camera. We may do this, we'll do this in the next video actually, getting the camera sorted. At the moment, we'll go back to the player and we'll get them rotating towards the mouse. Okay, so rotating towards the mouse, we're going to have a function here. Look at cursor. Now we're going to get the player's position. So variable player pos equals global transform dot origin. Okay, so that's going to get the origin of our object, the player in this case, and in its global position. Okay, so where it is in the global world, right? Because if we just get the player's position, it's just going to say 0, 0 probably, because that's where it is relative to itself. Now we are going to need to do something quite complex here, and I'm not going to attempt to explain it a whole lot, but what we're going to do is we're going to create a plane on the ground that's invisible. We're going to shoot an invisible ray from the camera through that plane, or from the viewport where the player's looking, through that plane, and get the location of the mouse, the mouse pointer, if it was kind of pointing or shooting a physics ray through there. And then we're going to calculate the vector from the player position to the mouse position on that plane and rotate the player object to point towards that. It's a little bit complex, so we're going to, and also once again I got this code from another video. I'm not sure which one it was though. It would have been a 2D one and I've adapted it for 3D. So we're going to create a plane, vector 3, 0, 1, 0, so it's facing upright at the player's position. And player pos.y is the up. We could actually say vector 3.up because it's the same thing. And then we go, well, how far do we want the ray to go? We'll just shoot it 1,000 just in case, but that's probably too much. I'll probably get away with 10. Variable mouse position equals get viewport dot get mouse position, and then variable from equals camera dot project ray normal, project ray origin actually, and we want to project it from the mouse position. So this is where the ray is coming from. Variable 2 equals from plus camera dot project ray normal, mouse position times the length of the ray, which is ray length. And then lastly, cursor position equals drop plane dot intersects ray, and from 2. Okay, so that's saying that the cursor position is going to be where the ray, which comes from this location and goes to this location, where it intersects it. And just so we can see how that works, I'm just going to print cursor pos. And then in our physics process, right down here, we're going to say look at cursor. Now, it's not going to actually rotate the player to the cursor yet, but it will show us where we are. Keep clicking the wrong one. That's the scene I want to run for now. You see down the bottom left there, it's giving it to us in actual world coordinates rather than global viewport coordinates. Like this would be 0, 0 on the viewport, and then this would be 1280, 0 or whatever. But we actually want it in world units, so that's -10. If you remember, each of these tiles is 2, so we can kind of figure out I'm 0, 0 there. I should be -2 roughly there, -4 there, and it's showing me down the bottom. So it's putting it into that world coordinate system. So let's go ahead and actually rotate the player object to look at that. So it's easy. There's a function called look at, and target is going to be cursor position, and then vector 3 dot up. So that's going to be the floor normal. You would think floor normal's down. No, it's not. It's actually up, because that's what we're seeing. The normal is the direction that it's facing. And you'll see here that I've actually got it around the wrong way. So we need to go into our player, edit our player here, and we'll go to 3D, and we'll rotate this, flip it to the other side. Why does it not snap? And then rotate it around that way. I'll put the 2D cursor, the position 3D over there as well. And then, wrong scene, save that, go back to test level, play that, and there it's now pointing towards our cursor. Next video, we'll look at adding that camera movement. It's currently, the camera doesn't move, so we can go around this corner and it hides us. But we're on the right track, so stay tuned for the next video. It will be up pretty much the moment that this video is uploaded as well.